Pythagorean theorems is, you can use it when it is a 90 degrees angles. Okay? You can use it as a 90-degree angles, and also if it's a right angles, you can be able to identify the hypotenuse. The hypotenuse is always the opposite from the right angle. It's always going to be the longest leg. Hold on. Okay, let's see. Oops. Okay. The longest leg. Okay, here it can be leg 1. Here can be a leg 2. Okay, so it's important for you to identify two things: right angles and the hypotenuse. Okay, it also mentions about in order for it to be there are two things. I want you to pay attention to this questions. Okay, there are two questions that I want you to keep in mind when you do all these problems. Okay. Okay, as you go through this lesson, I want you to keep in mind this one questions. Okay, I want you to keep in mind as you're going through this. I want you to identify or find out what is the difference between how the Pythagorean theorems, I'm going to add one more word, how is the Pythagorean theorem and its converse are used. Okay, find out what the word converse means, and find out the difference is the Pythagorean theorem. Okay, and then when we meet next week, I'll bring up that questions again. Okay, got it. Number 1 says that ask you to find the length of the hypotenuse of the right triangle with leg 1. One of the leg is 9 centimeter. The other leg is 12 centimeters. If I were to draw this, If I were to draw this triangle, okay, as I were to draw this triangle, it says, what is the length of the hypotenuse? It is unknown at this point. And then they say one leg, I'm going to say A, and then that's I'm going to say B. So A should be 9 centimeter, and then B should be 12 centimeter. Okay? How I'm gonna do this problem? I need to find out if it's a right angle, if there's an hypotenuse. Okay, is that enough information for me to find what C is? Okay, so I'm gonna bring back the equations of the Pythagorean theorem is. Okay, so I'm gonna do a substitution process. A in this case is 9, and then I square it. B is 12, and then I square it, and then C is an unknown. Okay, I'm gonna simplify this a little bit. Evaluate 81 plus 144 equals C squared. Okay, it's gonna give me 5 to 225 C squared. And then I'm going to take a square root. Remember, when you're talking about length, you cannot have a negative length. Remember, last chapter 9, we're talking about a square root. It's 2 answers. In this case, since we're talking about the length of a triangle, we only take a positive value. Okay, let's look at different scenarios. I noticed that there's a right angle. Okay, I also notice there is the hypotenuse. okay? And this is leg 1, and that is leg 2. Okay, the question asked me to find one of the leg. I still need to write down the same equations that's been given to me. So a squared, I'm going to set a squared because that's unknown. Leg 2 is going to be 12 square. Hypotenuse is going to be 15 square. Okay, it's going to give me a squared plus 144, 225. I'm going to isolate a, so I'm going to subtract 144. A squared, therefore, give me a 181. Again, I'm going to take a square root of that, and it's going to give me a 9. Since they don't give me a unit in this case, I always tell my students to write the word units. You don't have to, but it's good if you do, okay? So in this case, you work backward. You have the hypotenuse. You have the one on the leg. You're looking for the other leg. While this one right here, this unguarded number 1, you don't have the hypotenuse. You have the 2 legs, so you just technically add them together. Let's take one more example. Okay, let's say I have a triangle. Let's say I have an A to be 40. I have a B to be 41. Okay, I'm gonna find out what C is. Okay, my questions is this a Pythagorean triple after I find out what C value is? Okay, in order for me to answer if it is the Pythagorean triple, I need to find out if the one is it a right triangle. If it's a right triangle, do I have a hypotenuse? At this case, it is a right triangle. So therefore, before I can answer that question, it is by Pythagorean triples, I have to find out what value of C is. Okay. Okay, I have the answer to be C at this point, is 57.3 units. It is a Pythagorean theorem, okay? It satisfies the theorems, but it is not a Pythagorean triple. In order for this to be a Pythagorean triples, all three numbers need to be, the three numbers are the hypotenuse and the two legs need to be non-zero whole number. Okay, cannot be a decimals, cannot be a fractions. They need to be non-zero whole number. Therefore, if I were to have something like this one, and the units of 9, and this one right here, this is the Pythagorean triple. Okay, Pythagorean triple. It is the Pythagorean theorems, and it's also a Pythagorean triples because it satisfies the rules as non-zero whole number. Okay, it has to be all three to be non-zero whole number. Okay, let's look at the first questions. First question said that could this information be the right triangles, and explain. According to what I got, I squared the 20, I squared the 47, and I squared the 42. Okay, and then I combine them together, and I have 2609 on the left side, and I have 2704. They're not equals to each other. I can make a conclusion that no, it is not a right triangle. In order for it to be right triangles, both sides need to be equal. Okay, I have done this situation as they asked me if A and B and C satisfy the equation A squared plus B squared equals C squared. And then I have this information. I'm going to simplify it. 4B squared, 4C squared. Okay, and then I'm going to factor it out. Okay, in order for it to know if it's satisfied, I have to bring back this equation. I need to bring back this theorems. Okay, I know C squared is the same thing as A squared plus B squared. Okay. Okay, I think I make a little typo right here. I'm gonna take that out. Okay. Let me go back to green. I'm going to close it. The square is supposed to be right there. Okay, so since this satisfies this information, I just need to substitute it in. So I should have 4 substitute the C square equals to 4C squared. So the left side equals to the right side. And the question is, are there the possible side for the right angle? The answer is yes, because when I tested, both sides are equals to each other. Okay, if you have any questions throughout your homework, please write it down, and then we'll talk about it next week.